Hi, we are Group 10. So today we are presenting our cloud-based project, Automatic Number Plate Recognition, ANPR. So ANPR is quickly becoming an increasingly popular solution in different areas like offering organizations an effective visitor and car park access management and vehicle theft, security concerns, as well as like the growing interest in smart parking solutions and automated vehicle identification. So, automatic number plate recognition is a technology that uses optical character recognition (OCR) to read vehicle registration plates. Initially, ANPR was used by police forces around the world for law enforcement purposes. However, it soon entered the security market as more and more providers saw the benefit of utilization this solution for applications such as electronic toll collections, parking management, and smart parking, etc. So basically, ANPR is a type of camera that automatically read vehicle number plates as they approaches, allowing these details to be compared against the database records. So this camera takes an image of vehicle number plate, which then passed on to a reader that locates a vehicle number, and then it converts a valid number plate into standard winged format ID numbers. This data is then analyzed by access control system, which decide whether to allow or deny access to this vehicle. So if the access is verified, then the controller sends a signal to the barrier or a gate to open, else not. So in our application, we are implementing a pre-trained model, and it will extract the license plate of vehicle images and through the OpenCV, and then it trained the neural network to predict the segmented characters and further connect to web development. So as the user interface, you will get the option to sign up, and then you can upload the image of the number plate, and the model will recognize the number from it through GCP Vision OCR and extract the plate text and displays as a extracted number. So to explain it further in details, I will ask Daniel to take it over.
Hello. So I'm going to quickly talk about our backend as well as the REST services that we use in our project. First, let's see our db.py file, which is going to be our backend. At the top, as usually, we have import libraries as well as define some of the basic variables like username, password, and database name. The first function is going to be open connection. We use this function to establish a connection with our SQL server using this command over here. So we provide our credentials such as user, password, and host, and we return a connection. Next, we have a get user function. We use this function to display all the existing users. So first, here we fetch all the users, and then we print them. This is just to see if all the users are fetched. Now, if length of our user is more than 0, which means if we have any users, we're going to store them in variable, and then we're going to print them out. Next function is going to be add users. With this function, we can add a new user by specifying a name, email, and a phone number of a user. Next is going to be a delete user function. With this function, we can delete any user by providing an email address of the user. Similarly, update function. With this function, we can update a phone number by providing an email address of an existing user. And lastly, we have add plate function. With add plate function, we can add a number plate of a vehicle that's number plate already been predicted. Now I'm going to talk about a REST services, which are described in the REST server.py file. So the top part of this file is going to be covered by Dnyanesh, who's going to be covering the deep learning part. I'm going to jump straight to a users function. So this function has two methods, post and get. So first, if the request method is post, we will add a new user. Otherwise, we will return all existing users. I can quickly demonstrate this to you on a postman. So the first method is going to be a get users. If we press on send, this should return all existing users. And down there, we can see our current users added. And the next is going to be a post method with which we are going to add a new user, which is going to be me. Percent. We can see it returns user added as we added a new user. So after the users function, which has two methods, post and get, we have a delete user function. This function uses a delete method. With this function, we can, as discussed previously, we can delete any user by specifying an email address. Similarly, update user function, which is a post, which uses post method. We can update any user's information. Lastly, we have a get prediction method, which is again post method. And this function can predict number plate and add it to our database. Now, Dnyanesh is going to be talking about a deep learning part of the code.
So thank you, Daniel. So as Sonal introduced about our project, we are developed one web application using the Google Cloud Services for detecting the number plates from the vehicles. So in that context, we deployed deep learning algorithm with the use of TensorFlow 2.8 model, and we have used neural architecture of the SSD Inception version 2, which provides the 42 milliseconds image frame processing speed and with the 20T COCO milli average precision. So basically we are using this deep learning algorithm for object detection task. So as we mentioned in our web application, we are passing different vehicles images for the recognition of the vehicle's plate. So after passing the image to the deep learning model detects the vehicle's plate, right? So you can see over this slide, after passing this image to the DNN architecture, we are getting the number plate, right? And we are passing this number plate to the Cloud Vision API, which majorly used to uh, provide different computer visions methodologies, right? So as a face recognition, image labeling, optic character recognition, all these tasks we can perform by using the Cloud Vision API. So after passing this detected number plate to the Cloud Vision API, we can see we are getting the text as output, right? So this one is the number plate. So for developing this model, we have gone through different procedures. We have collected data from the web app Google by using the web scraping technologies. After that, we use some annotation uh, softwares for annotating the number plates from the images, and those softwares gives us output in the format of XML for the bounding boxes for the number plates. So we have to convert those XMLs into the CSV files and CSV files to the TF records for the making it compatible with the TensorFlow model. And after that, we train the model, and just we are using the pre-trained model in our web application. So there is no need to retrain again for each uh, input. So just we are using pre-trained model. We are just uploaded each in our project directory, and just we are as we are getting image from the user using REST API, just we are calling that model for prediction. So this is the hybrid model basically. So we are making the use of REST APIs to call the cloud API services. So here I'm going to show you the output of the file. So basically web applications cannot deal directly with the images, so we are converting images data to the base 64, and we are sending those base 64 input to the API or to the model, and we are retrieving this output in the same format in the base 64. And after that, again we are converting base 64 to the image and image to the text, right? So just I will show you the output. So here you can see I have passed this image in a base64 format to the our REST API, and if we run prediction on this, then in within a second we can get output about the prediction and the text, right? So as you can see, just I have sent input of image in B64 to our model, and our model is giving us output in the format of the B64, and this one is the predicted, this one is the recognized text from the image, right? So I'm going to show you here. So if we pass this B64 into the image conversion function, then we will get retrieved image. So as for now, we have discussed about the GCP SQL and the GCP Cloud Vision API. So now Nihal is going to tell us about the deployment procedure.
So, hi, thank you for that. So, as you can see, both my colleagues just explained how this project works on the back end and how this module was built. So, after this module was built, I'm here to talk about how it is being deployed. And for that, we use our Google Cloud Shell. We set up an account, linked it with the Cloud Shell, and then we use the key JSON file, which has the authentication details. We added it by adding the service account to our system's environment variable in our GCP Cloud Shell. After which, we downloaded the JSON file from GCP itself after the authentication was done. Now I'm just going to select the projects list. So I'm just going to type in gcloud projects list. Projects list. This command is going to show us all the current projects that are available. I'll just authorize this here. As you can see, that's our project, and that's what we use. That's what we're starting to deploy. We already did deploy it, so I'm just going to show you the output. This is used to build the Docker file. This is used to build the Docker image. This Docker file will have all the configuration details, the main application file, the path to the requirement text file. This text file contains all the library configurations for the app to run over the cloud, and then this adds all the details together in the image once and for all when the deployment is done. Each image is created on GCP as a storage bucket, and as you can see, that's the output: storage buckets and images. So after deployment, we will get the application running on Cloud Run. This is how the response of the application is after it has been run on cloud. And we are using CPU 4 cores, memory of 4 GB, concurrency of 80, and a request timer of 300 seconds. We can revise our deployment and our application if we want to modify some features later on. And yeah, that's pretty much how the application was deployed over cloud. And I'm going to pass on to my teammate Jasandeep, and she can conclude about the project.
So, hi. So, as my all colleagues discuss about the project, now I'm going to conclude this. So, I'm going to discuss the challenges in this project. So, there are many challenges in the domain of the NPR system due to various reasons. All these challenges affect the accuracy of the NPR system. It also affects processing time, which is also important for the system to be used in real-time applications. The challenges in NPR system can be due to external and internal factors. Challenges due to external factors of the NPR system can be classified into three main categories due to plate variation, environment variation, and camera mounting variation. So ANPR system is a combination of hardware and software. So these two should be chosen to make the better overall performance. So first one is technique and algorithm. Algorithm may require particular time to process, which is a challenge. And next one is hardware. So there are future scope for this project. Today, advanced technology took automatic number plate recognition system. So it's very limited, expensive, fixed based applications to be used in mobiles with point to shoot. This is possible because of creation of software which are on cheaper PC and also non-specialist hardware which no need to predefine direction, angle, speed, and size. So using these techniques, maybe we get in future we get very different projects and new projects. Now with closing remarks, this application is useful in many areas such as identification of number plates in parking or traffic regulation implementation. The GCP APIs encompass a wide range of problems, including AI, databases, and virtual machines. So this is all about our project. So thank you so much.